Hi, let us understand the need for distributed storage and distributed computing. Traditionally, we were storing all the data, whether it is a structured data or unstructured data, in a single computer system, and we were doing the processing or analysis on that specific data with a single computer system. Simple example, by using an Excel. And over a period of time, the technology on distributed computing got evolved, and the same data can be analyzed or processed with multiple systems in parallel. When we do that, we can increase the processing speed or the processing capability and get the result faster. And still further, the amount of data that we wanted to store grew drastically, and a single system was not sufficient enough to store the entire data. So we were doing a distributed storage, either using some distributed storage mechanism like HDFS or Alexo, or even in cloud. When we have the distributed storage, it will give enormous amount of volume to store the data, and distributed computing will give enormous compute power to do the processing. But to do the analysis on that specific data, the data needs to be read over the network. A network was acting as a bottleneck. Reading a huge amount of data over the network, the I/O was acting as a bottleneck, and we were not able to leverage the entire distributed computing as well as the distributed storage. That's where the methodology of doing the processing near to the data got evolved. Whenever the data getting stored in multiple systems, every system will have its own compute power. So the frameworks like Hadoop, Spark got evolved, where the data would get distributed across multiple systems. At the same time, the processing also will happen near to the data, and the result would get collected and consolidated. This is where the methodology of doing the processing near to the data got evolved, and this was helping to do the processing on enormous amount of data in a very short duration. And the technology got improved, and lot other processing environment or the processing methodology got evolved, like machine learning, which demands huge amount of compute power as well as huge amount of iterative calculations. When I say iterative calculations, doing the processing on the data again and again and refining the result till we get the recommended results or the satisfactory result. Whenever we read the data for processing, and after processing, we will be storing it back into the persistent storage. And the storage was acting as a bottleneck. Always the storage I/O is the slowest I/O within the computer system. If I have to do any iterative processing, say for example 50 iterations, I have to write the result, intermediate result, back into the persistent storage. So there was a need to cache the result and read the result from the cache and do the processing again. So maintaining cache in a single system is fine, we can handle it by having the data in the RAM. But if the data is very huge, we cannot handle or we cannot cache the entire data in the RAM. That's where there was a need to have the distributed in-memory computing, and that's where Apache Spark comes into picture. Apache Spark maintains the data set or a collection of any data across multiple machines in the RAM, and the processing can happen in individual systems and keep the result back into the memory. So the memory or the cache will be shared across multiple systems, and I'll be in a position to do the horizontal scaling of the memory as well as maintain the data in the memory, and that is facilitated by Apache Spark. Welcome to distributed in-memory computing with Apache Spark, and we are going to use Spark SQL in specific to handle some structured data.